Hi, my name is Leland Green, and this is my Physics 2211 Constant Velocity Lab report. So, to start off, the purpose of this lab was to observe the motion of an object in the real world. From there, we can analyze the motion and apply Newton's second law, or the momentum principle. We can then visualize the differences between theoretical motion and motion in the real world using computational models and real-world data from GlowScript and Tracker respectively. While the real-world data is close to theoretical, it is not exact. For this experiment, the system was the trolley or the cart, and the surroundings were the friction, air resistance, and everything else. Newton's second law is also known as the momentum principle. It relates the net interaction between the system and surroundings to the observed motion of the system. The observed motion is a change in momentum. When mass is not changing, we can use the equation force equals mass times acceleration, and that helps us get to the momentum update formula, which is the final momentum is equal to the initial momentum plus the net force times the change in time. So for this experiment, we have a couple fundamental principles and equations. So number one is the momentum update formula, which I just covered, which helps us get to the velocity update formula, which is the final velocity is equal to the initial velocity plus the net force divided by the mass times the change in time. And also, as a note, the position update formula is the final position is equal to the initial position plus the average velocity times the change in time. The procedure for this experiment was to 1. Record the trolley moving at a constant velocity, import the video into Tracker, and analyze the change in position for each frame. Create a computational model in GlowScript based on the initial position and average velocity that we get from Tracker. Use a spreadsheet to compile the position data from both Tracker and GlowScript, and then graphically and visually compare the results. So from Tracker, the trolley moves along, and you can see the small red dots which show the change in position. GlowScript also created this position versus time graph for us. And while the position has a negative slope, indicating a negative velocity, that is because Tracker interprets the trolley's motion as moving towards the left or in the negative direction. This model also helped us obtain the fact that since there's constant velocity, the initial velocity, average velocity, and the final velocity are all the same. The average velocity is equal to negative 0.7845 meters per second. The initial position was also revealed to be negative 0.0022116 meters. So next, I created a computational model in GlowScript, and I updated the following. So the initial position and the initial velocity to match what was determined from Tracker. I changed delta t to reflect 30 frames per second, the net force to be 0, and then I used the velocity update formula for the velocity and the position update formula for the position. And so this is the graph that GlowScript generated, mirroring Tracker. Side by side, the graphs are very similar, but the real-world model from Tracker is slightly different, and that obviously shows that there's some force acting on it that was not accounted for. So sources of error could be rounding, discrepancies in tracking the motion in Tracker correctly, or outside forces such as friction and air resistance. And they could lead to both major and minor discrepancies. So some additional questions. If the x-axis was flipped, positive and negative x were interchanged, how would the results change? Well, if that were to happen, the results would show a positive slope. The graph would still show that the computational model overestimated the position due to outside factors. If the net force is 0, how many forces are added together? There are other forces acting on the trolley, meaning the net force was not quite 0, as shown by the difference between the computational model and the Tracker model. This is almost certainly from air resistance against the trolley, friction against the trolley, and then another factor could be gravity pulling down on the trolley. In conclusion, there's almost certainly another force acting upon the trolley, as seen in the difference between the data, and that is most likely friction. Newton's second law also provides us with equations that assist in determining the net force, momentum, and velocity, And then computational models can be helpful for visualizing theoretical motion. Thank you for your time, and I hope this was helpful.